Hi and welcome to this video, which is the last in this sequence on aqueous chemistry. In this video we're going to look at acid-base indicators and how you select an appropriate acid-base indicator for an acid-base titration. And really just a very rough run through of what an acid-base indicator actually is. So first thing, acid-base indicators, which you will have all used in a titration at some point, are themselves weak acids and bases which have different colours for the acid and its conjugate base. So what that means is that as the pH of the solution changes, then the weak acid is converted to the conjugate base or vice versa, and the colour changes. The most important thing though is that when we're using the acid-base indicator, we want the colour change to happen at or about the equivalence point of the titration, because the indicator is what tells us when to stop the titration. So it tells us when we're hitting that equivalence point. So we need to have that colour change happening at the right point. And in fact, what we know is that the indicator will change colour when the pH of the solution is within 1 unit of the pKa of the indicator. Okay, so what you're really looking for is one where an indicator where the pKa of the indicator is similar to the pH at the equivalence point of the titration. Now let me show you a little bit more. Here is an exam question. This one was from 2019. It's a titration between methanoic acid, which is a weak acid, and sodium hydroxide, which is a strong base. You've been shown the titration curve, and then you're given 3 indicators and asked to select which one is the most appropriate one, and then explain why you would choose that. I want to show you in a little bit more detail. If we have a look here, here is our titration curve. Okay, the equivalence point for our titration is somewhere around about here, or roughly 8. We've got the 3 indicators with 3 different pKa's. Now remember I said that the pKa is an indication of roughly at what pH the colour will change. So if we think about thymol blue, I might keep my pen blue for this one. Thymol blue has a pKa of 1.7. That means it's going to change colour when the pH is here. That's actually not going to help us very much at all, because actually when the pH is there, that's even before we've started the titration. So thymol blue wouldn't change colour at all throughout this titration. So that is not appropriate. Bromocresol green has a pKa of 4.7. That means that the pH, that the indicator will change colour at around about 4.7, somewhere between 3.7 and 5.7. So we're looking in this region. Now that's not the equivalence point of our titration. We don't want the titration to stop then. We want it to stop where that blue line is, just a little bit further along. Now it's not far off, don't get me wrong, but it's not good enough. You won't get an accurate titration if you stop there. Cresol red has a pKa of 8.3, which is about here, which means that it is going to change colour here. Now that is exactly where we want it to be. That's the one we're going to tick, okay, because that pKa of 8.3 is very consistent with the pH at the equivalence point. Now how do we go about answering this question, which says explain your choice, including the consequences of choosing the other indicators? So let's have a quick look at that. Well, this is how I would answer it. I'd start by talking about from the titration curve, it's clear that the equivalence point is going to be slightly greater than 7. So it's important that the indicator has a pKa that's slightly greater than 7, because the colour of the indicator will change when the pH of the solution is equal to the pKa of the indicator. There's a typo for you. The only appropriate indicator to use is Cresol Red, which has a pKa of 8.3. If either of the other two indicators is used in this titration, then the indicator would either not change colour at all, which would be thymol blue, or would change colour after approximately 24 mL of base has been added, which is before the equivalence point. You could go on to finish that off and say, therefore, you would not get an accurate indication of the equivalence point at this titration. So that's what we're looking for when questions come up about acid-base indicators. These are quite unusual questions. There's usually only one every 2 or 3 years at most. The question I just showed you is 2019. So personally, I would be reasonably surprised if there was a question on indicators in 2020. But you can never be sure, and this information will be useful for you moving into university as well. I hope you found this sequence of videos useful. If you do find any mistakes, please do indicate in the comment box below. Otherwise, good luck with your exams, and I hope everything goes well for you. Thank you very much. Bye.